Live event, yes. To our audience around the world, welcome to JavaScript the Hard Parts, object-oriented programming. I'm more calm and relaxed than ever because we have a nice chill audience here of only a small number of people because it is a Tuesday and that is not our regular day. But I'm thrilled to welcome them. So let's have our more intimate audience welcome our online viewers with a hello world.
Hello. Hello world.
Perfect, lovely. We're going to go around and we're going to share our resources we're using, and I encourage you to note them down because they're very valuable. But Anne, kick us off.
Yeah.
What resource do you want to shout out, my friend?
My name is An. I use the resource for JavaScript. It's the JavaScript definitive guide, and also use Project Euler and Code Wars.
Project Euler and Code Wars, Euler and Code Wars. Fantastic problem solving with code. Do not just go watch tutorials. Go see a challenge and then go watch a tutorial to solve the challenge, not go watch the tutorial. Thank you, Anne. Appreciate it. Welcome, Anne.
How's it going? I'm Garrett.
Garrett.
Yes.
Welcome.
How's it going?
I'm good. Good to have you here, man.
Told you I'd come.
That's very nice to have you here. Because Thursdays are a busy day for you.
Yes, so
But
probably
Tuesday.
this Thursday, but I should be able to make it next.
I'm not too devastated, Garrett. Orders together. Go ahead.
Right.
Welcome. What is the resource you want to shout out?
So the one that comes to mind, we spoke about it on the phone actually, is the ReactiveX tutorials.
Oh, they're good.
We sent
Yes,
today.
they're very good.
Very good for functional programming, as well as understanding basic data structures and how to traverse them.
Yeah. Shout out to that. ReactiveX challenges. They're hard to find. You search on Google, ReactiveX, JavaScript. It's not the first, not the second result. I think it's like the third result or something weird, but they're very good. Really good. Created by Chuck and Hussain from Netflix. Very, very nice. Welcome, Garrett. Thank you, man. Welcome.
Hey, my name is Krishna.
Welcome, Krishna.
By resources, you mean where I sit and learn?
Yeah, or as you build or grow, what resources do you use? Maybe Stack Overflow, it may be, any place. What is it?
I think the best I've observed in my experience are Egghead.io and Angular.io.
Yeah, okay, that is good.
They're good. Probably YouTube is the best feature. A lot of people on YouTube. And
I feel that, man. We love MPJ. Fun function on YouTube. Phenomenal instruction ability. Thank you, Krishna. Krishna, thank you, my friend. Hello.
Hi, I'm Rochelle, and the resource I've been using is FreeCodeCamp.
Love it. Big fan of FreeCode, man. Love to have you here, Rochelle. Thank you. Hello. Welcome back.
Kawa and Front-End Masters.
Oh, where I will be performing my shtick in a few months' time. So you're going to check me out on Front-End Masters alongside such luminaries as, one of our Ronald's down here 2 weeks from now. He's down here to give intimate roundtable dinner with students and a big public talk, I imagine, as well, which all of the rest of you who are not Smith residents will be allowed to attend. But he'll be giving that insider information at the roundtable dinner. Anyway, Keller, welcome, Keller. Good to have you here. Hello.
And my name is Robbie, and
Robbie.
RBI.
Nice name,
And
man.
I like Code Academy, Code Fights,
Yep.
Udemy, JavaScript, which I think is JavaScript.com.
Oh. Wow.
Yeah.
It's been sitting in plain sight this whole time.
Yeah.
Okay, I'll go look that up. Thank you, man. I didn't know that existed. JavaScript.com, I'll go look it up. I'm not being sarcastic. I really didn't. I will go look it up. Is it good? What is it?
Well, Code Academy owns the domain.
Do they really?
So they
Oh, it's that funny little get started thing where you sort of,
Yeah.
once you complete it, it funnels you into code.
Yeah.
I saw that, yeah. Okay, I wouldn't desperately shout that out, but yes, it's good enough. Thank you, Robbie. Thank you, man. Good to have you here. Hello, welcome back.
I'm Justin, and I'm just cruising through FreeCodeCamp.
Very cool. Thank you, Justin. Who's to your right, Justin?
My name is Philip. I use.
Hello, Philip. Welcome back, dude.
Thank you.
Been a while, is it? Or not?
It's been a while.
How many months?
More than a month.
Okay, not too long. Welcome back, dude.
So thank you. I use FreeCodeCamp. That's great, and also use John Duncan's book.
Oh, the pretty one, the very one last
Pretty
time.
nice.
Yeah, the black cover with it. Yeah, it's the right there. Thank you, man. And who is to your right?
It's Christopher.
Welcome, Christopher.
Thank you, sir.
He of Black Tux CTO friendship fame?
Free Code Camp has been my big one for the last few days. When I get stuck, it's been a lot of MDN.
Yeah.
And,
MDN is like your reference guide to JavaScript, all the features of JavaScript.
W3 Schools is pretty good for
Yeah, I think it's the easy version of MDN, and no bad thing. I'm a big fan of simple English Wikipedia that takes the complex Wikipedia articles in regular English and makes it nice and simple for people like me. I think the W3 Schools is the equivalent of that for MDN. Thank you, Chris. Peter.
Peter, use Free Code Camp, HackerRank for problem solving, and the Hacker Prep.
Oh, very nice. Excellent. HackerRank, like Project Euler, like Code Wars, like Codebyte, a bunch of nice algorithm challenges to work through, and presumably with HackerRank as well, you can see solutions of others as well afterwards. No? I haven't seen that. Well, then I really shout out Code Wars because it literally has, once you complete the algorithm, you get to see someone else's solution, all the other solutions, and which have been upvoted for code cleanliness and basically the kind of quirky, cool solution. And you can see how they've been upvoted or downvoted, which is really nice. And you'll learn a bunch of best practice approaches by seeing what's been nominated as the best solution to the algorithm you just solved. That's on codewars.com. Very much like that. Thank you, Peter. Welcome back, Melissa.
Thank you. I've just been using YouTube.
Have you had a haircut, Melissa?
No.
Oh. I always like to say that to every single person, just in case. Go ahead, Melissa.
Just YouTube and Linda and Udemy, just signed up for Udemy.
Yeah, which course on
A React course.
Okay. I would offer some caution before you start doing the React course, the Node course. If you're already a mid-senior developer, post-hosted level, great. If you're not, if you're journeying towards that, it does risk feeling really good without necessarily being high value, because you're not necessarily autonomously problem solving, which is most of what it is to be an engineer, as opposed to just the knowledge piece you get. Because it doesn't stick, and it risks being like better is to get a deep understanding of object-oriented programming, of functional programming, and then start building something, and the React bits follow from that. Christian's got to start as a retail. He's got to start as a retail group.
No.
Thanks, Melissa. Hello, welcome back.
Hi. Senior.
Senior with the longest last name in history. Only 7 syllables.
I also have a country name. Yeah, I use FTN and then I was reading JavaScript and watching.
All good stuff, all good stuff. I didn't hear about any challenges you're doing there, so make sure you're using those to facilitate you doing challenges.
Well, Elephant JavaScript has a little bit of FTN.
That is true, actually. That is true. All right, people. So, here we go. Oh my goodness, Jarvis the Hard Parts OOP, kill me now. Let's do this, everybody. This is going to be intense. Is this pen good enough? Yeah. Can you, do you mind, Robbie, just go in and ask anyone on that side for a bunch of the narrow, the relatively thin line ones, pens, relatively thin ones, yeah, and black and blue, dark ones. Thank you, ma'am. All right, everybody. So, when we write large-scale, complex code bases, when we're trying to build large, everyone's laptops closed, my friends. Thank you. We'll have plenty of time in the pair program. We'll dive into our laptops. Now, we will not. So, when we write large-scale code bases, what I mean by that is highly complex application. So we're talking about a game, or there's potentially got 10 multiplayer playing at the same time, or whatever it might be. We have lots of data in our application. Let's say every user has a bunch of characteristics or whatever, and lots of functionality that we want to apply to users. Increasing their score, deleting the user, adding the user, having the user battle another user, having the user battle 2 other users, having the user I don't know, score go up by 7, go down by tons of functionality. Applications are basically data and functionality. That's what an application is. When code bases get big, because complexity gets, because it gets complex and lots of features, it gets hard. Thank you, man. It gets hard to maintain. Really hard to maintain. It becomes something where another developer adds this feature and it conflicts with your feature. You need a predictable way to structure your code such that it is easy to maintain, to add new features to reason about. That means to think through what it's doing, and that it's also efficient, performant. That means it's not sort of overly slow or wasteful of your computer's resources. There are a number of paradigms, ways of doing, structuring our code bases. One has been enormously popular for nearly 30 years. One is newer, or at least has blown up in the last few years. What is that one that's been very popular for nearly 30 years? The paradigm of structuring our code bases. What is that structure, Garrett? OOP. Yeah, well, that's not what it says up there, but exactly. What we're doing in JavaScript. What's the one that's been blowing up recently and becoming immensely popular, especially in JavaScript in the last few years? The alternative paradigm. No, functional, yeah, functional. Functional, you can have OOP for MVC as well. Functional programming. But we're going to talk, so when we do other parts of our parts, higher order functions, closure, or callbacks, closure, that's functional programming. Tonight we're doing OOP. The thing about OOP is that unlike functional programming, with functional programming, when you learn a closure function, like once, it's instantaneously useful to you. You can be writing your first line of code, and it's useful to have a once function. A function that lets you only run it once. That's a useful function. That uses closure. OOP, we have to be a bit more hypothetical and recognize that it exists to handle more complex code bases at scale. So we have to almost imagine that we are, no, that's not what we're going for, that we're building a quiz game for users. Here are a few of our users. We're massively simplifying, like those irritating professors do at college. Let's hold everything else constant. We're going to have name Will, score 3, name Tim, score 6, and the only functionality each of these users will have in our game is the ability for their score to be increased. And our goal here is to structure our code base such that suppose we had millions of users, or thousands of users, or thousands of quiz questions, whatever it may be, we have some structure to make it maintainable. Well, that means easy to add new features and easy to work with. That is our goal of tonight. We're going to see specifically what that means in a moment. But for now, what would be the best way to store this data and functionality in the same place, such that the functionality is there right next to the data when we're writing our code? What would be the best way to wrap those things up together, Robbie?
Objects.
Objects, good, thank you, Robbie. Objects, we store our functions with their associated data. What are functions which are associated with data known as when they're all objects? Robbie, what are they known as? Not functions, they're known as? What are they called when they're attached to objects? Methods, exactly, yep. So, our goal is, Robbie was going to say it anyway, but I kept cutting across him so he didn't get a chance to even say it. I apologize, Robbie. Okay, so, here is, I want you never to forget the whole of tonight. Here is our fundamental goal, is to be able to do this. This is amazing as a developer. To be able to know that the functionality, all the functionality we could ever apply to an object, to the data, some data. So we represent the data of the user in the application in an object. To have all the functionality we could ever want to apply to that user right there adjacent, so I can do this magic thing. So I can write user1.increment and know that the increment functionality is available on the user1 object. This is my goal when I do my object-oriented programming. That I am certain that user1 will have all the functionality that I could ever apply to it attached right to the user1 object. That is my goal. That makes my life as an engineer amazingly easier. Now, when I want to, and someone else picks up my code base and wants to add wants to use the user objects, use the users in the application, maybe make a new quiz game, a new quiz view, or wants to present the users in a different part of the application. They do not need to worry, what is the functionality that could be applied to this user? Oh shit, that's not available. No. It's all available directly adjacent to the user object. When I'm writing my own code, I'm moving the user from one view to a controller, to a mock. Is the functionality available? Yes, it is. Always available on the object. This is a wonderful way of structuring our code. And it is always our goal for our object-oriented programming approach. All right, we'll come to a second, dude. Before we come to it, Krishna, we are going to map through this in hard part style. Who has been to either callbacks or closures? So knows our approach. Okay, we're going to map through it line by line, and we're going to see this play out. Very, very simple. But it's going to get us into a baseline of shared understanding before we go deeper. So, how JavaScript runs: execution context, thread and memory, call stack. I am going to move through this fairly quickly because many of you have been to hard parts before, but we're going to still go through as regular. But we're going to say, JavaScript, when it runs, does two things. Firstly, it runs the code line by line. Line 1 says, store object. Line 2 says, run function on object. That's the doing the code line by line. That's our thread of execution. Thread of execution. The other thing it does is it stores stuff in memory. Line 1, store in memory an object with the label user1. That is our memory. And we can track through those two things. That's all we're going to do. And when we do that, it turns out most of our debugging issues and most of our reasoning becomes much more natural. So, here we go. Line 1. Garrett, line 1. What is the code telling the JavaScript interpreter? That's the thing that has the thread in the memory. What's it telling the interpreter to do?
It's telling it to stick that in memory with a name.
Yeah, so I like colloquial explanations as much as anyone, but you've got to match it also with the sort of more sophisticated versions. What's the posh way of saying that as well? What's the posh way of describing that first line?
I'm not sure.
Declare a variable user1 and assign to it
That object.
that object. Great, try it again.
Declare a variable user1 and assign it with that object.
Yeah, very nice. And we're going to store that variable in global memory, aren't we? Because we're right at the global level of our file. We're not inside a function. We're not running code inside a function. We're at the global level. So first thing is user1, and it's the whole object. So talk me through the assignment of the object quickly, Garrett.
So you've got name, will.
So we've got a name property, will, a score property,
3,
and
increment function.
yep.
User1 score plus.
Right, so we're not going to go inside it, we're just going to add it as a definition attached to this method name, to this property name, increment. Okay, and there it is, the whole anonymous function, doesn't have a label, has a property name, not a label, stored under increment. Okay, Melissa, we've finished with our user1 object assignment. Next line, what happens?
Run increments.
Yep, an increment method, so when we start executing a method, what do? We create a brand new
Execution.
very nice. No, we'll create a new call stack. Who said that?
I did. Sorry.
Robbie.
Sorry.
That is an L, as I learned as a recent phrase. That was harsher than I expected. Sorry, Robbie. I promise to endorse you repeatedly for the rest of the session. Melissa, you're right. We create a brand new execution context because we're calling a function. So, Robbie, can you remember, because you're basically speaking to it there, can you remember what happens in terms of the call stack when we start calling a function, Robbie?
It gets put onto the bottom.
Exactly. So our call stack is a feature of JavaScript that keeps track of where we are in our code. Are we running our code globally? That means line 1, line 2. Or have we started running a function and now we jump inside the function? Our call stack keeps track of that, of the calls to functions that are made. It's the stack of calls. If we were then to call another function inside of increment, that would be another call, and that would be added to the call stack on top. So the first thing thrown in the call stack is user1.increment. That function is thrown in, and now that's the top of the call stack. Now JavaScript knows, where am I? Where am I in the code? Don't worry, I'm inside user1.increment. It's the top of the stack right now. When it finishes running, it'll be popped off the stack and will go back to the global execution context. So right now in the local execution context of increment, it has a local memory. So any variables assigned get stored in the local memory, not the global one. Let's have Peter. Well, what does it say? What's the first thing it says inside of there? Inside the call to increment.
Increment the user one score.
Yeah, so go look at the user1 object. What do we find?
The score equals 3.
Yeah, and what do we do with it?
Increase it by 1.
Good. I want really strong technical communication, everybody. This is our obsession here. It is the reason grads get senior roles. No question. Is quality of technical communication. So we're going to get a chance to learn from this. Peter, I'm going to try rephrasing that. We look to the local memory for a user1 object. We don't find it. We look to the global, we find a user1 object. We look to the score property on the user1 object. There it is. And we increment that score property to 4. Did you see that precision there? All right, man. You going to do that next time? I appreciate it, man. Good. All right, so what alternative techniques do we have for creating objects besides this, what's known as an object literal? And it's been already filled out. What alternatives do we have for populating an object? Millie? Yeah, go ahead, Robbie. Do you want to have a shot with it?
You do this,
Yeah, that's going to come later. Don't worry, we're going to get to that. We're going to get to that in a big way. You want to go into it, Chris?
Constructor.
Yeah, that's what we're going to get to. By the way, we're going to do a very pathway between that's not using the constructor. Robbie? Oh, Rob, have you been to the session before, Robbie?
No, I just kind of was, that's that whole code academy. Dot notation, right?
Yeah. Dot notation, excellent. Very nice, Robbie. That's not the thing I thought you were talking about, but yes, here we go. User 2 using dot notation. We're going to walk through this very, very quickly. Line 1, Keller. Line 1, what's happening?
It creates a variable with the name user2.
Yep, good. Yep, and what are we assigning to it?
Empty object.
Empty object, good. And then what are we doing in line 2?
Line 2, we are referencing that object and then giving it a property of name and
Good.
assigning a value of 2.
Oh yeah, not will. My self-obsession. Continue. And then what else?
Then just the same thing, but with the property name of score and
Yep.
assigning the value of 6.
Oh, yeah, good. Keep going with us.
And then it's doing the same thing with a property called increment, which is a function, and the value.
Very nice. There's work to be done, but I think Keller deserves a round of applause for that. That was very nice. Well, Keller, keep it up. So, good. There's a final way. What is the final way? We're not talking about generating objects. What is a final way where we can just, in a single line, create an object? There's actually an alternative way which we're not going to use, but what is a final way? Senya, do you know? I mean, you sort of said it, Robbie. Can you remember what it was?
But create an empty object? Like an object that just...
But do you remember the syntax with a special way of doing that gives us a bunch of bonus features? Krishna, do you know the special way of doing it?
Assigning objects?
Garrett?
I forget if it's a class.
Yeah. No, okay, so we're all coming to these. We're coming to all these. It's this. Who's seen this before? Object.create. Okay. Object.create, this first line here, does one thing. It creates an empty object. So, after line 1 here, user3 is our label. What's assigned to it? You may think, some mysterious create not there. No, it is assigned an empty object with nothing inside it. The null is not the reason there's nothing inside it, just to be clear. We're going to see that if we pass something other than null, in a moment, we get a very, very powerful feature. Very, very nice. But that's to come. For now, line 1 has given us an empty object stored in user 3. Okay. Let's quickly race through filling it out, populating it. Let's give another shot to really clear technical communication to Philip. Line 2, what's happening?
Line 2, create in the user3 object
Yep.
a new property called name, assign a string of Eva.
Okay. We like this. Go ahead, Philip.
And then line 30 would be create a U. Just
A property score and assign to it.
assign it to a value of 9.
Yep. And then finally,
And then create a new method
Yeah.
called increment and
silent function. Good. Very nice. Our code is getting terribly repetitive. I was bored. That's why I tried to move through Philip, because we're breaking. What does dry stand for? Don't repeat yourself. Yeah. Suppose you have millions of these user objects. That's the whole premise of us doing this style, is it lets us create many of these. We're manually writing out each of these objects. Clearly there's not a developer sitting behind the game manually typing out each object. When we have functionality that is repetitive, and we want to do it again and again, how do we wrap up that functionality in programming? Yeah, with functions. So we're going to create a function that generates this object. Remember, our underlying goal is, with OOP, to generate objects that are relevant, in this case a user object, with the data that that object has, the user has, like score 3, name will, with the associated functionality, and produce a lot of them. That's our goal. Krishna, you don't stop swinging your share. That is our goal. There it is. Look at this magic. Simple, effortless approach here. Boring? No, very nice. But we're going to see hugely problematic. But it is solving, in a sense, our simple goal of producing an object with the data, the relevant data that gets passed in, and the relevant function, and then assigning it to these objects. It's doing what we want. We're going to walk through line by line, and then we're going to recognize this is fundamentally untenable. We cannot do this because of problems. But first we're going to walk through line by line. Chris, line 1, what are we doing?
We're declaring a function user and it's got 2 parameters names.
Okay, excellent. And what are we doing with that? So what does declaration mean in terms of our global memory, Chris?
It is going to build.
So we're assigning, or we're declaring a function that's going to be stored in global memory user. And it's going to, we're jumping in, well, next line. And I'm going to call on Jacob, no. Justin, sorry man. Justin, what's our next line of code? We've taken the function definition user, the whole definition and stored it in memory. What's our next line that the interpreter is going to run, Justin?
Let user 1 equals user will 3.
Okay. What did we notice, Millie, that Justin did there? What was our second line that JavaScript ran?
It went down to let user not necessarily a physical second line.
Yeah. Not necessarily, definitely not. Why did it not? What did it take for us to hit the second line of the second physical line, as you put it?
The function user you call hit the second line.
Right, very nice, Millie, thank you. So let user 1 equal the call to user. So the first part, the left-hand side there says, you know, declare a label user 1. What's on the right-hand side, Justin?
It is
Don't try and leap steps. Like what abstractly is going to be on the right-hand side?
right-hand side is going to be some data that will be assigned to.
That was so abstract. That was like one layer too abstract. Be one layer more specific.
It's calling function user.
Yes, and therefore what is going to be assigned in the end to user 1?
It's assigning will as the primary name.
Okay, so I'm just going to jump. What is going to be assigned is whatever is the output of running this function. That's going to be assigned to user 1. The return value, this is a posh way of saying it, the return value, whatever thing, variable, or the value of that variable, that's immediately after the keyword return, is what this function call is going to evaluate to. It's going to become that output. And that output's going to be stored in user 1. So that's what I meant by abstract, not specific yet, but it's going to be the output of that function. You were wonderfully abstract by, it will be some value. That was good.
So a variable can accept an object also, right?
What?
Honestly, object, right?
Oh, let's play it through and see what happens. So, to get that return value, Justin, we've got to go run the function as you were about to do. So, Justin, we're calling user. We create a brand new execution context. So other words were being said there. don't know what they were, but yes, in execution context, there it is. And remember, an execution context is just, we had one at the start. We had a global one. It had the thread, which is where we did each line of code, line by line, and it had a memory, globally. When we start running a function, we create a local function execution context, where we have everything which we assign in memory gets stored in the local memory, inside the function, rather than the global one. Local memory. And remember, memory is just a live store of variables with the values that have been assigned to them. This is a live store of that data. There it is, and then our thread, we start going through our code line by line, but inside the function definition. Christian, go ahead.
Both global and local memory are stored on the browser, or are they stored somewhere?
They're absolutely stored in JavaScript. So are they stored in the browser? No. They're stored in the JavaScript engine is where they're stored. Are they stored in the browser? I would distinguish the browser from the JavaScript engine. They're not like in a local storage web API. So the browser has what's called APIs that have things like a local storage where you can assign. Local storage equals this data. That is not stored in JavaScript, it's stored in the browser. This is all in the world of JavaScript. This is just abstract. This is, honestly, to be honest, this isn't just JavaScript. This is true of any programming language. It has a memory. Okay.
Yeah. So where the global memory resides?
Technically in JavaScript, it resides in somewhere called the heap. Which is true of any programming language.
It should be the RAM.
Yeah, it's on the RAM, definitely. Yeah.
And this.
But dude, I would say this isn't too important for this. We can talk about this one-on-one for sure. We'll talk about it one-on-one. So, just because there's so much stuff to get through, we'll talk about this one-on-one. They're nice questions, but let's hold them. So we jump inside the function. What is the first thing? We hit the first line inside the function. Keller, line 1 inside the function. What's it tell us to do?
With the local memory, create a variable and assign it to the user.
Very nice. Yep.
Contains script source and empty.
Yeah, empty object. There it is. Now new user in our local memory refers to that empty object. So, given that, what can we do in the next line?
We can store things in it, so like
Yep.
the property name and then assign it.
I'm just going to use this left-hand side. I sometimes use it as my sort of working area, just like the stuff we're doing in the thread. So we're assigning name, and we're filling out this one. This is not a copy, to be really clear. This is just so we're assigning name, and what are we filling out name with? Oh man, sorry. Before we declare the empty object, Before we declare the empty object, what's the first thing that gets stored in our local memory?
Our name and our score.
Yeah, exactly. So name is what?
Name is going to be Will.
And score is?
3.
Right. So in this, name is now Will, score is now 3. Okay? And so talk me through this line, Keller.
So then it's going to create the name property and then assign it to the argument that we got passed in Will.
Yeah, we create the name property, name. Yep. And assign to it the name value that was passed in as an argument, Will. Good. And then score, again, 3, because name.score, we add the property dynamically, and then fill it in with the score argument. And then finally, we do what, Keller?
We give it a method, which is just an increment function.
There it is. We define it. Do we run it? No. So then we hit the final line of our function, and what does it tell us to do? Keller?
It just has us return that contain object and then have it stored in the variable we created using.
Yeah, exactly. So name will, score 3, increment is a function, and we take that new user and we return it out, and now out here we have name will score 3 and increment is a function. Look at this. We've achieved exactly the same as we did when we manually created that object. But I want to hold on to that object somehow. How do I hold on to this object? Keller's already said it, but what's your name? Rochelle. How am I going to hold on to this object that was returned? It is the output of running this function. How do I hold on to it? What do we think? Senya? store it in the user1 variable because we said user1 is going to equal the output of running this function. And so here it is stored in user1. If I have to write this object out one more time, I will be very frustrated, but it's all the same object. Score 3 increment is a function. Okay, good. We're going to race through this one more time. We're going to see a problem emerge. Let's have Anne.
Yes.
Line 1. What's the left-hand side? Sorry, line whatever this is. 3. What's the left-hand side telling us to do?
Left hand side will display the variable user2.
Yep. And what are we going to assign to it, Anne? Do we know yet?
We get there's a user this one assigned to user.
Yeah, but in general, do we know what the answer is yet? No, we've got to go run a function. How do we know we're running a function, Senia? Parens. Not arguments, that's not necessary. It runs if you put parens on the end. In JavaScript, you only run functions when you put parens on the end of them. So we're running the function. So if we're executing a function, Senia, we're creating a new
Execution.
Thank you, Anne. There it is. So we're calling user, new execution context. I'm going to do it here. It's a completely different one. This one's finished. This one's been deleted. It's done. We finished running the user function first time, gone. But now we're running it again. Okay, new execution context. It has a local memory. Senia, what's the first things in the local memory?
The name of the score name is a string 10.
Yep.
The score is 5.
Excellent. And score is 5. There we go. And what's in the first line inside the function, Senia?
Declare the variable user in the local memory.
Very nice. Very nice. There it is. Next line, Melissa.
Give it a new property of name and assign Tim.
Name and Tim. Next line.
Give the new property of score and assign 5.
Excellent. And then,
Give the new function increment.
yep. And there it is. Good. Now, final line, Melissa.
Return the new user as user2.
Very nice. Out it comes. And we have it out here now. With name is Tim. Score is 5. And increment is a function. And we assign it to user2. That means it's now, because it gets returned out without a label. It does not get returned out as new user. This label goes away when you return it. It just gets returned out anonymously. Just as the object. So you've got to store it, the output of this function, in user2. Here it is. And now we do our check. We do our sort of thing we're going to do again and again, which is, remember, our ultimate goal is to be able to... Our ultimate goal is to be able to do this. User1 dot increment. Because this goal here, this lets us write very maintainable code. Wherever we pass this user1 object between, one game in the application, into another view, into another piece of logic where we're trying to, always the user1 will have the functionality that could ever be applied to it. Now in reality, guys, that object will have 100 functions. Increment, decrement, delete user, whatever, hundreds of functions could be applied to that user. We want them all to be available directly on that object, but not only on that object, but on user2 as well, on all our user objects. That's our goal. So let's see if it is. User1.increment. Melissa, what's it? Talk me through this line of code, user1.increment.
Okay.
Just to be clear, sorry, we finished running user, so it got popped off our call stack, and we're back global. Now we're back global again. This guy's gone. Okay. Melissa?
Okay, so we've got Will is the name, score is 3. So we would go into user.increment and
Yeah, we can just go and look at where, we can just literally be really simple and go look in our global memory for user1. Do we find it?
is it still there?
Yeah. Yeah, definitely, because we said 2 lines before, user1 will be the output of running this function. We don't go back and run the function. User1 now is that object. It is that object that was returned out of running this function. We're not storing, be really clear, I see a little hint of confusion there. We are not storing in user1 the running of the function. No. We ran the function. It returned out an object. A full object. There it is, with name is Will, score is 3, increment the function. That whole object was stored in user1. So when we do user1.increment, we just go and look at what user 1 is and see name is Will, score is 3, increment is a function. So
So you just increment to 4.
well, let's be methodical. This is a function. So what do we do with functions? We create new.
Execution function.
Good. There it is. And it's very, very simple execution context. Does it have anything in the local memory? Any arguments? We have a look? No, nothing. We don't declare anything inside the functionality of this function. Increment. There's nothing declared inside increment. So all we do is we hit the line that says new user dot increment. Oh, sorry.
Score plus plus.
Sorry. Yeah. Thank you, everyone. Score plus plus. Okay. I'm not gonna. I hate going to this bit here. The reason new user is still available here is due to JS Hard Parts Part 2 closure. We don't need to worry about it. But the reason new user, because new user is not in the global memory, but it's still available because when it was declared, because of the wonder of closure. So come to Hard Parts. This is a real life version of feeling of closure. So no, not feeling of closure. Existence of closure. So yes, we go to user 1, find score, and increment it to 4. Okay. So our functionality goal has worked. Our functionality goal was to have user 1 be an object with all the data, and then be able to run the function increment on it. Our generate objects using a function solution 1 to our goal of producing an application where all our users are objects, and all the functionality could ever be applied to the user objects, user 1, user 2, user 500, user 1000, is there, right available. I could have instead done user 2 dot increment. And increment, there it is, a function on user 2. Okay. This is very powerful. We're going to 1 second, Justin. This is very powerful, but it has an enormous flaw. I'm going to see whether I'm going to mention it now or not. Before or after the pairing. I'm going to mention it in a moment. Firstly, thumbs. No idea what just happened. Clarification, clear and ready to move on. I understand we generated an object, we return that object out and stored it in a variable. Everyone's thumbs, no idea what happened. Clarification, it's okay now, clarifications. I'm clear and ready to move on. Okay, no clarifications. Let's come to Justin's and Robbie's.
So once that you run user by increment, is the new value stored when you call user 1 again?
Oh, definitely, because user one is an object with data in the global memory. So absolutely, yes. Robbie?
I had the same question.
Okay, good. All right, so there's a big problem with this. I'm going to make a look. Who knows what the problem is already? Who can see a huge problem with this? Senya, go ahead.
Maybe if we want to add a new method, we want
Oh.
to add it small.
Never heard that way before, but yes, that's actually very true. Very nice, Senya. We'll come to it. That's very. So Senya said, what if we wanted to add a new function that's available to all the objects? There are ways we could do it, but it ain't going to be simple. Very nice. Alternative problem. That definitely is a problem, and our solution will solve that too. But it's not the problem I'm most interested by. Philip?
It seems like every user we create still has the increment method inside it.
A brand new function. What the heck? This is it. This is the answer. Were you going to say anything, Color? This is a huge issue. In reality, it ain't going to be one function, and it ain't going to be 2 users. It's going to be hundreds, not thousands of users, all in global memory. And there's going to be hundreds of functions that we want to have every single user object, user 1, user 2, user 500, user 1000, all have that functionality available. And there's going to be hundreds of functions, increment, decrement, I don't know, user, compete with other user, whatever. We cannot have, think how fast it's going to become millions of lines of memory. So there's 100 functions, 1,000 users, each function's 10 lines long, 100 times 10, 1,000 times 1,000 users, you've got 1,000,000 lines, so to speak, of data or functionality being stored for 1,000 users, because each has 100 functions attached to it. And all those functions are identical. This increment function has exactly the same functionality as this one, but we've done copies of them. The data is unique. You literally need new space in memory because names Will, names Tim, scores 3, 4, 5. The functionality is copies across every single object. this is incredibly redundant, incredibly problematic. Robbie, go ahead.
I was just saying, so you would make the function global instead.
That is one solution. It has many downsides that I want to, well, you can just have it global and then run it on the object.
Yeah, instead of me.
But we've already said our goal is to be able to go user1 dot increment, because we want to know that the functionality is there right on the object. If we have a global function called increment, we've got to make sure wherever we go in our code, that function needs to be moved and available. And it makes it super unmaintainable. This function, we may only want this function to be used on user objects. We don't want it available to be used on all objects, everything in our code. No, no, no. We don't want a list of 1,000 functions, some of which are for one object type, some for another object, some for users, some for quiz questions. We don't want people writing code that says increment the quiz question object. We only want them writing increment the user object. So our fundamental goal is, can I write the functionality I need on the object directly using dot? Which is why we don't want our functions separately over here, even though that would mean one copy. It's going to turn out, Robbie, there is a way that achieves both these goals. All right, so problems. Each time we create a new user object, we make a space in our memory for all our data. Okay, fine, that's legitimate, and functions. But our functions are just copies. Is there a better way? The benefit is it's super simple. I totally get that I've created an object, the function is right there. If I run user1.increment, I'm not wondering where that function is, it is right there as a property on the user1 object. Super intuitive, but absolutely never used, and completely and utterly unrealistic, because it fails by making incredible performance problems by having copies of every function. Ridiculous. Okay, we're going to see better ways. That's solution one, Dan. We have 3 more solutions. So before we do that, we're going to go to pair programming. We're going to look at these 8 things you might have done. They're not levels, they're tally. I should edit this, but go through, give yourself a score out of 8. If you've only handled collisions in a hash table, but nothing else, your score is 1. If you've handled 6 of these things, your score is 6. If you've handled 3 of these things, your score is 3. So give yourself a score out of 8. You know what an object is. I don't know why I added clarification of in programming. This is incredibly patronizing. If you know what an object is, that's a score of 1. If you added a CSS style before, now a score of 2. And so forth. Give yourself a score out of 8. And you're going to stand up, grab your machines, line yourself up 1, 2, 3 over this side, 4 here, 5 here, 6, 7, and 8 over here. Everybody, jump up. Six is here by Peter. 6? 8. You're over here, Peter. 8. Oh my goodness, that computer engineering degree is doing you a great service. You're over here. Kala 7. Vanessa 6. 6. Krishna. Okay. Okay. That's fine. It's good. This is going to be a really interesting session. So Peter and Kala, the 2 of you are together. Vanessa and Garrett, the 2 of you are together. And Krishna, the 2 of you are together. Philip and Robbie. What? The gentleman standing behind you. Creeping behind you. No, he's there. You look on the wrong side. He's there. There you go. Him. The guy in the pink shirt. Okay. Yes, poet.
They don't have computer.
Oh, you know how to have a computer?
Yeah.
You came to a workshop on OOP without a computer. Okay, it's fine.
I can share with them if you want.
Why don't we have Philip and Anne?
Yeah.
Okay, man.
Yeah.
And then we'll have Krishna and Robbie. All right. And then we'll have Senya and Millie, and we'll have finally our final 3 here as a group of 3. Okay. Thanks, folk. Everyone grab a seat. We'll do fun. Thank you, everyone. This is a joke reference to how I use the word cementing as a concept. Very Anything cold? Oh. Okay, everyone. Let's talk about pair programming. Who has not paired for 4 days? Is he left for good?
I don't know where he went, but he
Maybe the bath.
maybe went to the restroom. That's okay.
Okay, alright. So, who's not paired for today? Gareth, you paired?
Sort of.
Okay, well, let's just remind ourselves how to do it. Remind ourselves why it's important. Pairing is an all-body workout on those 5 capacities that we look for in candidates that make a great engineer. Problem solving, technical communication, well, all over it. Very, very powerful because it encourages and forces you to keep going, talk through your code with clarity to your partner, and problem solve and reason about your code verbally. Which is very effective for improving your problem solving. So, how do you do it? Well, we have Keller and we have Peter. Keller and Peter, we're just talking about pair programming, Krishna. So we have Keller and Peter. Keller and Peter see a problem. The challenge says, I have no examples, one example. The challenge says, declare a function, or, yeah, not declare a function. The challenge says, append to the DOM the 10 latest tweets from the Twitter API. So the first step is they do research. So it's the research stage. So they go to Twitter's documentation, they see that they get very conveniently an array of 10 tweets as 10 strings, unlikely, but let's go with it. And then they go to jQuery's documentation, they see an append method, but they see a vanilla JavaScript alternative to the append method. Well, this is the research stage. Then Keller goes, Peter, I've got a set of how to do this. Do you mind if I navigate? And so Keller says, all right, Peter, I'm going to navigate Peter, you're driving. Peter, please declare, I mean, you probably would be quite so unfriendly. Peter, I'd be very grateful if you were to declare a function, append tweets. Give it the parameters, tweets array, to be an array of tweets. And in the body of the function, we're going to iterate through that input array, each element, string, element, and append it using the jQuery append method to the DOM, and we'll append it to the DOM element with the class name tweets container. And now, Peter has his hand on the keyboard. At no point did Keller put her hands on the keyboard. She was fully explicating verbally. It's hard, but it's powerful fun. And then Peter is turning that into code. Function, append tweets, open parens, tweets array, close parens, open curly braces, for, open paren, var, I equal net, I, and so forth. Okay. Very nice. Peter thinks Keller's giving him bad advice, but he doesn't take it down for it. He lets let's get to the point where they can press run. Then if there is a problem, they get to debug it, and he gets to mentor through reasoning about it. And half the time it turns out she's got it right, and just approaching it differently to how Peter would have done. That's it. That's pair programming deal. Very powerful approach. You want to do it here. One machine between the two of you. The Wi-Fi is up here. The challenge you're going to work on are at csbin.io/OOP. And if you hit a block, please raise your hand because a fellow will come over, an engineer from the team will come over and they will guide you through. So csbin.io/OOP. Off you go, folk. Alright everyone, get to the challenges. I want to hear lots of loud pairing.
Just more space.
Yeah.
Excuse me, can you guys move a little bit? Can I have more space here? Because you guys have the more space there. Okay, and you guys go like this. Okay. I guess you guys have
Cool,
thank you. Okay. You right. Okay. Thank you. Yeah, what? ES5.IO slash OOP.
It's gonna be an extra variable.
Yeah.
Yep, sure.
Well, first you need to.
It's gonna be an extra.
I love word.
Good job, us.
I love perfect.
This part is for basically.
It's necessary that unless you're going
I'm barely starting.
Yeah, okay. Actually good. Okay. This function will create the object.
So, you want to talk next time?
Talk about just one before moving.
No?
Empty object, okay. And then you have name property. New object is value in name. What the? We have to understand what the.
Because we have to do it one line.
Okay.
First, create a function to input function.
Yes. Yeah.
And return an object. Okay, so
To return the object.
and then this function make person.
Yes.
This function will create an object.
Yes, to create empty object like.
So, like let's say.
Okay. Then return it to return that one for you. Okay.
And then our line for in the middle is here.
And the name property. They have the new created object. New created object. So maybe you create a new and the property. What you call it? Name. New name or what?
Yeah, we call it just name.
So if you name it to equal to this one.
Yeah, you can do the same name.
No, that's we're confused, you know.
Oh.
But then make it new variable, you know.
Yeah.
Because you have new object, new variable, yeah, new name. Okay, this time.
Oh, you can talk about it.
Oh, you do it. Yeah, you cut your computer when you're comfortable with it, you know.
It's new object. You want to call it new name.
Yeah, how do you think? Equal to name, right?
I mean, that's fine. It's still fine. Both are still the same. Like new object.
Oh, okay. Yeah.
We'll just
Is that okay?
Yeah.
Okay, value the name argument. Okay.
Okay, that's the only thing is
Okay, Jen.
so I guess we will.
Yeah. I think the age will be the same. There you go.
Right, so now you're
You don't want to do it?
yeah, we can switch back and forth.
I think we can run this way. Now it's control.
Okay, inside of.
Yeah.
Okay. This type of stock object. Oh, this one? Oh, wow, wiki. Oh, the test is done. One test is. Okay, so wiki and so it's good, okay? Yeah, that's the one they want to say. Now let's go.
Wait, so
First thing, just in case something happens.
That's not happen, right?
Computer freeze, like, oh no.
Okay. Now, on the channel 1.3, inside of person, small object, create property, create, where, function, type of okay, maybe
So function.
value is a function. So
Pass in the object.
I'm not sure why they are.
Yeah, that's colon, seven, two colon. Is your equal sign? Yeah, it's like two semicolon, two colons.
who call it? Oh,
I mean,
oh yeah.
yeah, colon. There you go. Should work. There.
Okay. Oh man, don't be
You create person stock.
okay.
Let me give it a shot.
I think this just actually just means that it's on.
Okay. Create function for the non-text input as the name. When called, the function will create it's really easy, right? Because when called, the function yeah. Okay, so then
So when we call it down here, person object. Person stop object. When person stop object, where is that? Is that person stop object from here, right?
Yeah, so
when called, the function will create object.
Alright folks, can we get a round of applause for our helpful fellows? Yes, excellent. Round of applause. Thank you. Good. Thank you, gentlemen. Thank you, gentlemen, because we are now moving back. Everybody close your laptops. Sorry, everyone. Sorry, John. What an exciting day in US politics, by the way. What a fascinating day. And Nixon moments, as they call it. Was everyone closely following?
No, definitely.
FBI Director Mr. Comey.
And Frank's president too.
He was fired, and the last time that's ever happened was Nixon, and Nixon was very corrupt.
And by the way, that person later was brought down.
Yeah.
Or was he initiated the investigation that later brought down? Right, so here we go. So we realize this first approach here is flawed, right? We're doing one thing right. We've created a function, user function, that inside of it, let's be really clear, user function is just a function that happens to inside of it create an object. We then fill in that object with any of the parameters that were passed in, return out that object and store it in user 1. Then we run the function all over again with Tim and 5, create an object inside, fill it in with stuff, return out user and assign it to user 2. Yes, we can do our ultimate goal, dot increment, but traumatically, the increment function is generated and copied onto every single user object. This is not efficient and not maintainable. So we have an alternative. Solution 2. Store the increment function in just one object. Store the increment function in one object. And then, if the interpreter, when it tries to do user 1 dot increment, tries to run increment, doesn't find increment on user 1. Instead, it goes and looks at that one object and finds the increment function there and uses that one instead. That's going to require us to make a link to that object where the shared function, the single copy of the function is. Yeah, we've got to make that link. How do we make that link? What's that word everyone loves to say in the world of object-oriented programming in JavaScript? How do we make that link?
Inheritance.
I would be very cautious to use the word inheritance in this. Someone said the word. Prototype, Celia, correct. It's going to feel like inheritance from other OOP languages. Do you come from an OOP language?
Yeah.
Which is?
C#.
C#. Okay, it's going to feel like it. It's not analogous. Well, it's analogous, but it's not the same. It's this wonderful magic thing called prototype. So let's see this in action. Solution 2 in full. We're just going straight to it. There we go. All right, so what this says is we're going to have some special object where our function increment that could be used on user 1 or user 2 or user 500 or user 1000, that function is not going to be on the object. Gone. It's not going to be on the object. Instead, we're going to have some sort of, I don't know, shared setting. Oh, where's the black one gone?
Here.
Oh, thank you. Some sort of shared function store which will be an object in which we will find increment, the function. And somehow JavaScript will know when it doesn't find increment on user 1 because it's not there anymore to go looking in this shared function store and find increment. Somehow it's going to know to do that. Okay. We're going to walk through this line by line and how to build that bond. It's going to be hard. Solution 2, folk, is the answer to one of the toughest senior developer questions you can get asked. Which is, we're going to see what that question is, but solution 2 is the answer to one of the classic senior developer questions you can be asked. Solution 3 is the solution everyone else does, and the answer to the question related to it is solution 2. So we start with solution 2. There you go. You're going to feel very proud of yourself when you've done solution 2. But it is hard. So remember, always holding in your mind, folk, what are we trying to do? We're trying to have some way to produce objects that have our data on and our functionality available on every single user object. Or, by the way, we could generate quiz questions Once you start thinking of your code as object-oriented, you think of everything as objects. So in this application, as well as a quiz game, you'd also have quiz question objects. Quiz question 1, quiz question 2, each of them is an object. Quiz question 1 has a functionality display, to mean have it displayed. That's still a functionality on the quiz question object. When you start going OOP, you start doing stuff like an object for your application, a single object, which is your application object. You start doing everything as objects. All right. So let's have line 1. Oh no. Here it is. Solution 2 in full. Here we go, guys. We're going to start with Justin. Line 1, Justin. What are we doing in line 1?
We're declaring a function user with putting it in the local memory.
Very nice.
And
That's it, man.
okay.
What else are you going to say? Just get out why you're doing so well. Well, what else are you going to say?
So, like next line? Or
Yeah, next line. What's next line?
Okay. So you're going to look at, go down to let user 1 equals.
Oh, there's one thing. The next line, if you can see what the next line would be, Melissa.
Declaring the object user function store.
Yeah, do you see that before? It may look maybe a bit hard to spot, but here's our function definition, user, stored in memory. The next thing is this line here.
Oh, yeah.
Because we don't go inside the function, so we hit the curly brace, and then we go find the closing curly brace, there it is. And now we hit this line. So we grab the whole definition, and now we hit this line. So Melissa, tell me what happens.
So it's got a property of increment, which is a function.
So it's user, what's it called for user function store, is it?
Yes.
And it's an object, and we assign what properties to it?
We're assigning increment a function.
Okay, increments assigned a function. Do we go inside that function definition, Melissa?
No.
We don't care. We don't care about the details of the definition right now. It's just sort of black box. For people who haven't been here before, we draw our function definitions as black boxes that we don't go inside until we start running them. Okay, Melissa, next line. Or sorry, what's the other thing we do?
Another property login, it's assigned another function.
Okay, so look, already here we're using two function definitions, but they're both assigned to this user function store. Okay.
Can I ask a question?
Yeah, go ahead, Anne.
Can we declare a variable instead using let?
Oh yes, so just be clear, let is just an increasingly popular alternative to var. It's just a variable declaration.
Okay.
Sorry everyone. Let is just a way of writing var. It has a number of properties that make it better to use, not necessary to go into here. Just wherever you see the word let, replace it with var for now. Okay, it declares a variable. Thanks, Anne. Next line, Melissa.
Let user 1 be.
So what is that saying?
It's saying run user with these parameters.
Correct. What's the left-hand side leave us within the global memory? A label of
User 1.
user 1, exactly. What's assigned to it, we don't know yet, but we know it's going to be the output of running user. So we've got to run user. Talk me through the steps when we start executing a function, Melissa.
Okay, there's a new execution context.
There it is. There it is, excellent. And it's got the arguments.
Parameters of will for name and scores 3.
Right, so let's look at that local memory then. So that, oh, and also in terms of our call stack, we're calling a function, so
Push onto the
call, yeah, exactly. Push the call onto the call stack. And now anything that we declare, our thread's gone inside the function. That means we start doing the code line by line inside the function. And anything we declare inside this function, any variables, or let declarations, are going to be stored in the local memory, not in the global memory. So local memory, here it is. Garrett, what's the first thing that we have inside the local memory?
We're gonna have new user download.
We've got a few steps before that, dude. So what's the very first thing that goes inside that global memory?
We're going to pass in an object I create.
Oh, still a few steps before that. So the very first thing are our arguments. So yeah, so what's the first thing in the local memory is? What's the first pair of variable and value, or sort of argument, label, and value? What's the first pair?
Will in 3.
Not quite. What's the first pair, Melissa?
Assign will to name.
Right, yeah, so name is initialized with Will. And so Garrett, what's the next one?
Score 3.
Excellent. Thank you, Garrett. There it is, score 3. So now we've handled everything up to the start of our function. We filled in, name has been filled in with Will, score with 3, and now we hit this line. What's the left-hand side of that line, of the assignment? Just a simple let new user. What's that telling us, Melissa?
Declare new user.
Yeah.
It's not.
Well, yes, you're right, but let's just say for now we have a label, new user. What's going to be assigned to it, Melissa? Can you remember?
An object.
It's an empty object. An empty object. Do you remember how we did that? Object.create. This is an alternative method of creating an empty object. And yet it has something going on here, right? We're going to see what that might be. So, it creates us an empty object. So to remind ourselves, I said we want to be able to write user1.increment like that. And we want to not have on the user1 object, we want the user1 object to just have on it name, will, and score 3, and no increment function, but somehow for JavaScript, when it looks for increment on the object, doesn't find it, to not panic, not say error, no increment, but to somehow go looking up into this object in which we have the increment function ready to go. We want to build that bond somehow, so that JavaScript knows to go and check up in its backup function location. Oh, I didn't find increment on the object, user1. I'm not going to panic, because I know it's definitely not there. If I did user1.name, will, no problem. User1.score, 3. But user1.increment, it ain't there. But I don't panic. We want JavaScript to somehow know to go looking up to this function object, this object full of functions that we've created. That was our goal. So if you want this object that gets returned out of running a function to have that feature, when would be the right time for us to make the bond, Peter, between that object when it was born inside this function, originally called new user? When's the right time to make that bond to the user function store?
When you're declaring the user function?
Exactly. When we're creating the object inside. And in fact, that's what we do. At the object creation moment, when we create that empty object here, we make a special bond up to that shared function store using this special built-in JavaScript functionality. The built-in JavaScript functionality that says, this line here says, create an empty object, object.create, there it is, but not just an empty object. It is just an empty object, but with a bonus thing. A special bond up to the user function store, such that this object, if we were to write inside of here new user dot increment, it would go look not just in the user object, but if it didn't find increment there as a property, it would go look in its backup, this user function store. Melissa, go ahead.
So is that a superclass for
No.
user?
It's a helper.
No, let's be careful just throwing, don't worry about words. We're going to come to what all this stuff is called very soon. Is it a superclass? No. But people who come from OOP languages, what's your OOP language?
Java.
Okay, if you go from Java or C# or C++, be very careful trying to apply that paradigm of thinking that you have from there to OOP and JavaScript. It is not the same. It may appear on the surface somewhat. We're going to go with how it is here for now, and we'll see what these things are called in a minute. All right. So for now, we are running the user object with the inputs of will and 3. We're on line 1 inside the user object. We're on the user function with will and 3. Name is now will. Score is now 3. We created an object, empty object, with a label new user. But that is not just an empty object, it's an empty object with a special bond up to this user function store. So, now let's keep going. Let's fill in this object. Millie, we hit this line here. New user is an object, and we're saying add a what?
Name property?
Name property and assign to it. So there we go, name property, let's just add it in. Name property, there it is, now the name property's been added. And what are we assigning to it?
Will.
Yeah, the name will, perfect. Thank you, Millie. And then the next line?
The score property?
And assigning to it? 3. And then, oh, it's a very small object, there we go, nothing else. There it is, there's the object. And then what do we do with that new user object now, Millie?
We return it.
We return it out. Very good, Millie. We return it out. Out it comes, it has name is will. And it has score is 3. So, now we've finished running user. Popped off the call stack. We've finished running the user function. Execution context closed. But we've popped out, we've returned out this object. Senia, what's our label for this object now, globally? User 1. We said whatever comes out of running user with the input of will and 3, store in user 1. So, in it goes to user 1. So user 1 is now the object name will score 3. There it is. And that is stored in, who asked that? Robbie? Well, yeah, because we ran user, we returned out the object that was created inside, back out to the global and stored it in a global variable user 1. There it is, user 1 in the global memory. Okay, Robbie? So, let's run this one more time, because we want to run it for user 2. May get repetitive, but it is very crucial. So, Garrett, let user 2 equal the call to user. Talk me through what's happening in this line. What's the left-hand side tell us to do?
So the left-hand side tells us to declare a variable user 2.
Yes, very nice. What's on the right-hand side? Do we know yet?
The output of the function user.
Very good, Garrett. So we've got to go run the function user. So we run the function user with the input of what?
We're going to input Tim and 5.
And 5. Great. And we're going to create, Garrett, can you remember the name of it? A brand new?
Execution context.
Excellent, my friend. And it has a local memory. And of course, Garrett, because we're now calling the user function, what do we do with the call stack?
We're going to add user.
Yes, exactly. We'll add the call to user, or the execution context of user to the call stack. There it is. Now we jump inside user. Garrett, first things inside the local memory.
It's going to be name Tim and score 5.
Excellent, score 5. What's our then first line of code inside the function description tell us to do? Because we're now running this line of code. What's it does do?
It's going to tell us to run object.create user function, or passing in user function stored.
Yeah, so that's literally what it says. What does it tell us to do? What's that? So we've declared a new user.
To create a new empty object.
Empty object, thank you, ma'am. There it is. There's the empty object. Stored in memory. And it has something more, doesn't it? Peter, what has it got more?
A special link to user function store.
Yeah, exactly. Special link to user function store. Meaning that if we were to run on this object when it gets returned out, dot increment, we're going to see this in a second, we're not going to panic that it's not on the object, user 1 or in a moment user 2, which is going to be the output of running this user, running the function this time is going to be user 2, the output of running the function this time is going to be user 2. We're not going to panic because there's a special bond. How is that bond stored? I'm just going to tell you right now. It's stored like this. When we declared this new user object using the object.create approach, when we declare the user object using the object.create approach, this bond is stored in a special property that we can see if we open the JavaScript console. It's not a property that, like name or score, that if we were to console log the object, we wouldn't see this property. But if we were to press that little down arrow, it's a hidden property. It's there, and that hidden property is called __ proto _. And that, stored on that is the user function store. It's not a copy, it's just a link up to the user function store object. So if we were to click on proto, we'd see this object, we press a down arrow, we'd see it's the increment and login function. Not a copy. It's just a reference up to this object. So JavaScript knows that it's got a little bond. That's how the bond's stored. In a hidden property, underscore, underscore, proto, underscore, underscore. Who's encountered underscore, underscore, proto, underscore, underscore? At some point, yeah. That's where it's stored. All right, so let's keep going. Senia, we've created the empty object. It's got a special bond to this shared function store. So all our objects will have so this object will have that bond function stored, and that bond is stored under this proto property. So Senia, what's the next line tell us to do?
We're going to add a new property name to
Yep.
the new user object
And
assign it name, which is
very nice. And a new property
score.
and assign it.
The score, which is 5.
Yep. And then what do we do with this new user object?
Return it to the global.
Yeah, there it is. Return it to the global execution context. Out it returns. And what does it have in it? Name,
Name
Tim, and score 5, and of course a hidden property that's a bond up to the function store. So it has a hidden property that's a bond. This guy has that hidden property as a bond. And what do we do with this object? We store it in what's here?
and user to
There it is, in the user2 variable. That object is over here now with name, Tim, score 5. And of course, just going to throw them in here, and of course our special underscore proto underscore user function store, that is to this shared function store. Same thing here, hidden, we can't properly see it, underscore proto underscore to that user function store. Okay, so Peter, before you close your eyes, we are now going to run user1. Remember, our fundamental goal is to go user1 dot increment. And remember, we want that increment functionality to be there. No problem, no pattern oh, it's not there. We want it to be there. Is it there on user1? No. So what are we going to do?
It looks at proto,
Yeah.
and then it goes to that object and sees if it has increment.
Yeah, and what does it have it?
Yes.
So what do? We start running it and we create a new, let's do it over here, user1 dot increment. Where do we find that increment function? Well, on the user function store that the user1 object has a special bond to, and there we run the function. What did the functionality say? It said this dot score plus plus. Okay, the wonder of this is a whole separate talk, but in practice here, the this points to the relevant object that this function is being run on. Because this increment function could be run on user 1, user 2, user 500, user 1000. We don't know yet what it's going to be run on, so it has to, if it's going to point to the object, it has to automatically, that this is going to be assigned to the user 1. Whatever that function is being run on, the this is going to point to it. So this is like a placeholder that's going to make sure that when we write this dot score plus plus, what's this going to be? Don't worry, the increment function is being run on user 1, so this will be user 1. So Peter told me through what's going to happen here.
It's gonna look at user 1 and check its score and increment the score by 1.
Excellent. All right. Okay, guys. That's it. This is not everything, obviously. It's solution 2. Let's have thumbs. We have created a function that we created a function. We have created a store in an object of additional functions that we want every object that gets returned out of running this function, which is this object, this function returns objects. We want every one of those objects to have access to these shared functions so that we can write user1.increment run it, user500.increment run it. That's our fundamental goal. That's our goal. And we managed it that even though user 1 and user 2 do not have the increment function on themselves, they have a special hidden bond under underscore proto underscore to the user function store, so JavaScript goes looking there. All right, let's have thumbs. Why am I here? Clarification. Okay, clear to keep going. Anne's got clarification. Melissa's got one. Garrett's clear. Robbie, clarification? Clear? Okay. Let's go to Melissa.
I pretty much get it, but what's this concept called?
So, this, I hate the term for it because I think they're inaccurate to some extent, or they're confusing. This here is called the prototype bond to user function store. And what we will say when we do object.create user function store, we are setting new user, and therefore the returned out user object user 1, user 2, we're setting the new user prototype to be user function store. This is the prototype of user 1. This is the prototype of user 2. What I dislike about that is we're going to see in a moment with solution 3. All right, does that answer the question? Okay. And this whole concept is called prototypical or prototypal, and then the word I really hate, inheritance. Because there's no inheritance. You're not getting copies of these passed down. They're not being put in objects. I would call it prototypical referencing. Maybe that's a better way. It makes a reference up to this prototype, such that when we call user1.increment, we don't find it there. JavaScript automatically goes and looks up here because of the bond we made at the birth of that object to this shared function store. Okay, Anne.
Why don't you declare the increment and login function in the function user?
You come from an OOP language as well. Exactly. This is standard practice in OOP languages. We don't do it here. I mean, because you want a single copy of it. If you declare inside a function, it's going to produce a new copy of user function store every single time. We're going to get a very nice what's called syntactic sugar in solution 4 that's going to finally solve your worry, Anne. Don't worry, solution 4, here it comes. Solution 4 is the final solution we'll have to handle. Okay, but no problems with this approach. No problems. This is a beautiful approach. I love this approach. This explicitly stop creating rival meetup groups, Krishna. This approach explicitly shows what we're doing. We are making a bond to a shared function store. Very explicit setting of the prototype. Solution 3, which is the most mainstream solution, everyone uses it, it hides a lot of this, meaning people don't know how it's actually working. Maybe it's a little bit long-winded. Inside of user, we're creating an object with a bond, and we're returning that object out. When you start using OOP, you end up creating functions all the time that inside create objects and inside return out objects. So maybe it's a bit long-winded. You have to write create a new object, return it out every time. But it's only 6 words, super sophisticated, but not standard. This is absolutely not standard. You will rarely see this. But it is the answer to the question that people like to ask about solution 3. So, what is solution 3? What do we think is the solution that achieves this concept that is the standard approach to achieving it? What is the key word that we use? It's not prototype. Well, it does involve prototype. What's the key word we knew? Exactly. Keller's would be right. The word is new. Solution 3 uses the keyword new. Shall we do it now, or shall we do some more pair programming? We're going to do some more pair programming. No, we're not. We're going to keep going. Oh my goodness. We're going to have a 2-minute, 3-minute break. Go grab the bananas, food, stuff in the kitchen. 3 minutes, be back here, and then we're going to do solution 3 that is going to make all this much cleaner and prettier and fewer lines of code.
Can I ask you a question?
Go ahead.
You mean prototype? You mentioned about prototype. Does that prototype mean that bond function?
This function here is the prototype of these two because they have the underscore proto bond to it.
So how do you define a prototype in the technical?
That is the prototype, yeah. Oh, the prototype is any object that uses any object that JavaScript, any object that another object makes a prototype bond to. And the way the prototype one is made is through the underscore.
Wow, so
proto.
it's kind of a little bit complex.
Well, that's everything we've been doing here, yeah, dude. I mean, just keep playing with it.
Okay, thank you. That's the prototype, right? Maybe a prototype is kind of object like the other object reference.
How long will the class go to today?
Yeah, right?
An hour? Is that pretty quick? But if you need advice from people,
Do you know a lot about them? I don't want one that's too clicky, so
Okay.
blue, right?
Yeah, no blues, no greens. Clears.
And blacks you don't really feel that much, right?
These don't have any key cap color, but these are like a different switch altogether. So these are not actually the black switch. A black switch is like a switch.
Yeah, so you don't feel it very much.
It's like, yeah, there's no like, you don't feel like a bump.
Tactile response.
I just feel
Oh, Jesus. I think there's awesome Facebook messages of what the team has got. Yo! I don't know who the
I don't know, I know, I was looking online, I was like, oh, these look so badass, they're like $300, right? Was this one a lot?
yeah, it's one of the more, so that's why we just the switch.
What's the job that you would just know?
But like cherries, it's really good. Browns are okay, browns have,
I thought JavaScript
they're
was
not
object based.
Yeah.
I want,
I
I
don't know.
would do
It's
one
not
tactile a little
It's
bit.
not?
Yeah, but not
What you're
really.
seeing is right now, there's no anything you see in JavaScript around classes or object-oriented programming uses the prototype chain.
Okay.
So
You
what is
gotta
the
write that
difference
down.
between
Okay, okay.
Object-based is it?
Yeah, object based.
The objects are called in JavaScript, I guess. I don't know. Object-based.
There is no inheritance in JavaScript between objects.
I'm just trying to see what
The difference between object oriented and object based is object based don't have inheritance.
Okay.
Object oriented has
No object-based language may be used in a technical sense. So any programming language that uses the idea of encapsulating state operations inside objects. So this language need not support inheritance or subtyping, but those that do are also said to be object-oriented. That seems a reasonable solution.
So because it's not inheritance, there's no inheritance in
Yeah.
JavaScript.
Or subtyping.
Why isn't there no inheritance in JavaScript?
They chose to be a prototypal language.
Oh,
It's just design decisions of the creators of JavaScript. They go, do we want to be? Prototypal languages have been around, a bunch of different prototypal languages, and they use this special chain
What's a
of
lay-
those who inherit.
what's the layman definition of a prototype in general?
I mean, we're doing it right now. There's
That's
no,
no, that
there's no
I
such thing as layman explanation.
No,
You just-
prototype in an English context.
What are you working through? Yeah, like you can't sort of give layman clarifications. We have to build it up piece by piece. So we're going to come to it in a second. We're going to come to it. Don't worry.
Question.
Oh, wait.
Will I learn this out of the framework?
The framework doesn't have OP.
So I won't be doing anything.
You want me to do what?
I won't be doing OOP or
No OOP.
intense JavaScript.
Intense JavaScript, yes, but no OOP. OOP is just one piece of JavaScript. We chose not to teach it in framework because it's not worth. Actually, you know what? We do OOP, just not as comprehensively as this, because this is a preparatory thing for the code. So the code, you've got to understand all JavaScript by the time you graduate. But framework, actually, sorry, correct. We do OOP in the framework, but just much lighter than this. Okay.
I'm doing the framework.
Oh, nice.
Yeah.
That's good. Let's go right now. All right, everyone, come on.
Is that pretty beneficial for CodeSmith to be written first?
I mean, it's very nice program. I thought it was your, it's a very nice program. I do work with time because it is really good. But it's not, it will help you get in, I guess, but it's far from necessary. Only thing necessary for getting into CodeSmith is hard parts, one repeat, again and again.
So framework won't get you into CodeSmith.
It's not necessary. But having taught it now, I will grant it very much helps. It's definitely necessary. I would say from the framework, probably 6 people have been accepted for framework university so far. Out of maybe 60 framework students. So pretty good. But most of them go in again.
Are most of them good? Yeah. Do most of them go in apply to those as well? Or?
No, that's the thing. Framework is serving people who half of them do apply to get into jobs, yes, but they know that's not the point. And half of them do it because they just want to get Coast light experience.
Like I want to go to Coast Creek bad, but I work full time. And out here I don't have family out here. So I have to work 40 hours a week. There's no way to survive. You know what I'm saying? So framework makes it.
Alright guys, enough. We've got to keep going, otherwise we'll be here till 10 o'clock, and then what's that? Nobody wants that on a Tuesday night. So, although you did sign up for a central OOP, and although I did look at the meetup description, we used the generic meetup description from 2 years ago, it says 8 PM to 8:30 PM, diamond some coding. 8:30 PM drinks. So, I realized this was not descriptive. Here we go, solution 3. Introducing the magic keyword new. When we run the function user without the new keyword, what do? Let's just remind ourselves, because we've been away for 3 minutes. When we ran the user function without a new keyword in front of it, we created a new object inside with the label new user. It had a bond to a user function store. It was filled in with the properties, and then we returned out that object from the user function and stored it in user 1. Then we did it again. What was I going to do? Then we did it again. Create a new object inside, filled it with properties, returned out that object, stored it in user 2. And then we could write user 1.increment, and even though increment wasn't actually on the user 1 object directly, we looked in the in the proto bond and found user function store. Perfect. Good. Go ahead, dude.
I don't know if it's now, but can you add and remove bonds after you've already created an object?
Yes, definitely. There's a whole methods called like set prototype that can do that. Yes. We said no problem with this, except that it may be a little bit long-winded because we wrote inside. Oh, do you want to pull the door to a second? Thanks, man. What do we write inside? Remember, we wrote let new user equal object dot create, and then we passed in user function store, which made a bond, if you remember, made a bond up to user function store. Good. And then at the end we wrote return new user. Return new user, which returned that whole new user object. In the end, as I say, when you write object-oriented code, you end up producing these functions that return objects for everything. You produce a function that returns quiz questions, a function that returns quizzes, a function that returns an application, a function that returns views. Like everything becomes an object, a function that returns objects. Everything becomes an object, and therefore you create functions that return objects. So in a sense, you're always doing this: create an object, new user is the name of this object, fill it in with stuff, make sure it has a bond to a shared function store, return that object out. In a sense, that is repetitive. Write this stuff every single time. What if we could automate the creating of the new empty object, the bond to some shared function store, and the returning out of that new object? What if we could automate that? Because in other languages, that is automated. And so the designers of JavaScript said, well, given in other languages it's automated, maybe we can help out and automate it in JavaScript. And that's why they invented something called what? Keller? What do they invent? The new keyword. Sorry for asking you why your mouth is full, I apologize. That's why they created the new keyword that they insert, or that they let you insert in front of here, in front of the running of the user function. Right in front of the running of the user function, we can insert a new keyword that we then say let user 1 equal the running of the user function, but with the new keyword inserted before the running of the function. And that is going to take away a whole bunch of the code we had to write in here and automate it. When we call the function user with new in front, we automate actually more than two things, but two important things. One, we automate the creation of a new object. Before, we said let new user equal object create. Creates an empty object, stored a new user. When we insert the new keyword, we automate that line. We don't need to write it anymore inside. It's going to be inserted automatically by JavaScript for us. And we automate the returning of that object. That line is going to be inserted automatically as well. Okay, which means we're also going to be automating the bond to some function store. Let's look at it. The new keyword automates a lot of our manual work. We no longer have to write the line of creating the object inside the function. Because we're running the function with the new keyword in front of it, we no longer have to return out the new user object out of the function. That's automated for us. By using the new keyword, this line literally gets auto-inserted. This line gets auto-inserted. Okay. This creates problems. Not actual problems, but things that need to be adjusted. Who can see what the things that would need to be adjusted here are? We are now, before we manually created an object with the label new user. And then we filled it in. Do you remember? New user.name equals name. New user.score equals score. Now we're automatically creating that object inside of the user function using the new keyword. Keller, what adjustment might we need to make given that a lot of this stuff's now being automated? Before we manually made a object, new user equals, and then did user dot. What might we have a problem with that approach now? Who can see why we have to adjust something here?
We don't know what
Chris?
object
Oh,
is
Krishna, go ahead, yeah.
we don't know what object is called.
We don't know what it's called. Before we said new user dot, what you said thing, Chris?
I was just going to say it also depends on the prototype form.
Correct. Before, we manually made the bond to this function store or user function store. By the way, whatever we call it, as long as we use the name here, the bond's made. Now that's also gone. But Krishna's also right. Before, we knew to write, do you remember? New user.name equals name, and new user was an empty object, and we filled it in with stuff. Now we've got no object called new user, it's automatically created. So, Keller, what do you think we do? What do you think JavaScript does to help us out here? It uses this keyword. It automatically creates an empty object in here, and we don't get to give it a name, it gives us a name for it, which is the keyword this. I'm going to underline everything here that is done for us by the new keyword. Well, here's the next thing. That this is assigned to that empty object because of the new keyword inside of this function. The object gets created. You can almost think of it creating let this equal the empty object, object.create. And then the return is done as well. We've also noted, right, that we used to manually make a bond to this shared function source, which this object had a, do you remember, it had a proto bond to this user function store. That's also gone because the object's been created automatically, so we don't get to pass in user function store as the input to object.create. Now this line's gone. So JavaScript needs a place where it knows it's going to find the user function store. We've got to sort of come up with a default name for user function store. Right now we're manually saying, go look in user function store. If you don't find on user 2 or user 1, if you don't find increment function, go look in user function store because we pass in user function store into the definition of that object using object.create. That's now been done automatically. So JavaScript, we don't get a chance to say go look in user function store. We've got to know, JavaScript's got to know where it's going to find those shared functions. And it chooses a very reasonable place. It chooses a very reasonable place that we're going to see in a second. All right, so here's complete solution 3. We got rid of our create user object, gone. That's been inserted here automatically. We got rid of our return user object. That's been inserted here automatically. We got rid of our new user.name equals name, and instead we have this, which is the automatically inserted line here, dot name. this line here has been replaced with this equals object.create. So now this is that empty object. We're going to walk through this line by line. Okay, Garrett, it is your moment. Here we go, Garrett. Line 1. Actually, Garrett, you've done this a few times, so I feel you deserve a break. So instead, we're going to have Robbie. Robbie, line 1. What are we doing?
We have a function new user that has 2 arguments.
Correct. And it's going to be stored where?
In the global.
There it is. Oh, what do we call it? User with a capital.
Yeah, user.
Okay, good. Next line.
In the next
Robbie.
line,
Oh, this is hard. So,
it goes down to let user work.
nah, we hit this line first.
Oh, okay.
So here's the function definition, stored in memory.
Yeah.
Then we hit this line here. What is this line telling us to do? Well, in JavaScript, functions are both functions and what, Peter? What else are they? Simultaneously. Nah, objects. Functions are both functions and objects, simultaneously. You can think of it maybe as just thinking functions are objects that have a special property that let them be run. But they're basically objects. But there's, if you treat it like an object, if you treat it like a function, it behaves like a function. If you put parens on the end, it runs the function bit of it. But instead, if you write user dot, I don't know, score equals 3, then it uses the object bit of it, which is simultaneously there, which would then have score is 3. So user.score is 3 because now the user is an object, but also at the same time we could run user, and that would use the function bit of it.
So which function are you calling if when you say user and give you
This function.
okay.
This is a function called user, but all functions are objects, meaning as well as being able to run it like a function, we can add a property to it. So one way of thinking it is, here's the user object. It also has a hidden property on it called call or run, whatever you want to call it, and that runs its functionality version of it. So we treat it like a function and run it as a function. Well, it runs its function stuff, but it's also simultaneously an object. So
can I dynamically add any kind of a property on it?
yep, you could write any function we've ever seen. If you created a function, multiply by 2 is a function. It takes an input num, return num by 2. We can run multiply by 2. Multiply by 2 with the input of 3. It's a function. We run the functionality. Or we could write multiply by 2 dot name equals will. Doesn't override the functionality, that's still there, but if we were to do this, now if we were to then go multiply by 2 dot name, Krishna, what would we call, if we were to console log that, what would we see?
Will.
We'd see will, yeah. Now if we were to console log multiply by 2, just by itself, what would we see? Definition of the function, exactly, definition of the function. If we were then to sort of click the little down arrow in the console, console, we would then see the properties. Okay, functions are functions and objects at the same time. Okay.
Now if I say multiply by 2 dot id is equal to 5, would it append the number of properties and
Say that last bit. Dot id is equal to
5, let's say?
Yeah, it would just become now. You know, it would have. So there's a function. So we'd see if we were to console log multiply by 2, we'd see the function multiply by 2 num. And if we would press it and then the whole function definition return num by 2. If we were to console log, it would see that. But if we press a little down arrow in the console, we would see an object that would say right now name is will, and if we added ID, it would say ID is 5. It's just a regular object and a regular function at the same time. Okay. All right. So on that note, that means we can store stuff on our functions besides their functionality. It's absolutely unrelated to what's inside the function. It is it's unrelated. We can't, I mean, we could, but it's not useful to think it's being used inside of here. It is just a storage thing that's also available in the object, or on the function, sorry, on the function object. That's why you'll sometimes hear people call them function objects in JavaScript. It's just a function. But it has, hold on a second, Robbie. It has also an object. The user has two parts. User, so if you treat it as a function and run it as a function, it's a function. If you treat it as an object and run it as an object, it's got object properties on it. They're at the same time. We'll come to a second, guys. So, user.prototype. Man, so prototype is therefore a property of the user object. So user.prototype, because prototype is a property. But that is in itself, oh god, an object, which has a property increment and a property login. Oh my goodness.
So we basically created that on the fly then.
Yeah.
The increment and the login.
Yeah, there they are.
It's a nested property.
Yeah, that's what a nice way of putting it. By Krishna, a nested property. It's a sort of, the objects are nested inside each other. This object is nested inside this one, which is, sorry, these functions are nested inside the prototype object, which is a property on the user object, which is also a function. The function at the top there. Oh my goodness. Go ahead, Robbie.
This is real quick.
What trouble are you going to cause? And Robbie.
Solution 3, is this the most efficient
What?
way?
Yeah, go ahead.
Is this the most efficient way to do OPP?
OOP. Let's come to that, dude. Okay? We're going to see. All right. So we now have our stuff set up. Now we're going to run final line. Keller, final line. What's happening?
We are creating a new global variable called user.
And what a wonderful thing that it is not a function and an object. It is just a gloriously simple user1 variable label. And what are we assigning to it, Keller?
We're assigning it the results of calling a user.
Correct. So we're just going to say, for now we don't know, do we? So we're going to leave it blank, undefined, because we've got to go run the function user with this magic new keyword. So we start running a function, because it's just a function. It's nothing special, it's a function. We create a new what? Keller? Who said that? One on Krishna. Your name is not Keller.
But I thought you pointed to me. You were like.
All right. So what? So we're going to add the call to user to the call stack, and we're going to create a new execution context for the running of user with a little local memory. Okay. I'm going to be very clear. We're running it with the new keyword in front, and we're saying whatever comes. Oh, we're passing in will and 3 as input, and we're going to say whatever comes out the bottom of running this function with the new keyword in front. Whatever comes out the bottom is going to be stored in what, Keller?
User1.
User1. Got it. Whatever the output of running this function is. So we jump inside the function. Keller, first thing in local memory.
We have a main argument.
Yep, which is
assigned to will.
very nice. Or assign will to it, yep, and score
To 3.
to 3. Okay. Peter, what's the next thing in there that's done by the magic new keyword that got inserted? What's the first thing it does inside of our local memory?
Creates a new object.
Correct.
And assigns it to this.
Let's give a round of applause for that. I mean, this is exhausting and deserving of a round of applause. Well done, man. Yeah, he's right. Actually, there was a knowledge-based thing, I guess, so I don't know if it deserved a round of applause, but yeah, very nice. There it is. There it is. So we effectively did the line, this equals object dot create, which created an empty object. There it is. But we did something else immediately as well, which was what, Peter? Have a guess. What else do you think was done immediately?
Probably passive prototype.
before we pass, do you remember user function store? We've said we don't get to do that manually. This line here is never written by us, it's done by JavaScript behind the scenes. So it needs to have something to pass in here that it knows will always be there. And the place it has its user function store for the user function is this guy here. Oh, I think it's pink actually. Here's this guy here. It knows always goes to look on the name of the function that's producing this object with a new keyword in front of it, dot prototype, which is an empty object which we have ourselves filled in with two functions. It knows to go and look there automatically. So if we want this object that's going to be returned out and assigned to user 1 to have access to this store of functions, well, we've got to make sure that store of functions is under dot prototype of the user object / function. This is our automated place to go and store all those functions. We used to call this user function store. JavaScript calls it, we used to call it user function store. JavaScript calls it user.prototype, an empty object, which we then fill in with stuff. It's always there. Every single function has a dot prototype, but it only becomes meaningful because of the new keyword auto insert and makes a bond to it. Okay, very nice. So we can say that we passed in automatically a link to this dot prototype, or in other words, we can say that now on this keyword, on the this object, is an underscore proto bond to this dot prototype object, to this whole object here where increment is stored. So, Garrett, your lucky moment. We've done an automatically created empty object called this. We've given an automatic bond to the user.prototype object where all the shared functions are that we want this object to have access to. Garrett, now we hit this line. What is this?
This is our empty object.
Correct, Garrett. And what are we going to add to our empty object, Garrett?
In that first line, we're going to add name.
As a property? Yeah, as a key, yeah. And what are we assigning to it?
The argument name.
Which is what?
In this case, Will.
Excellent. And then property?
Score.
And the value? 3. And then we get one final thing that's automated. I'm going to come to Peter for this. What's that final thing that we said got automated because of the magic keyword new? And note everything in green is the automated stuff because of the keyword new. We're not writing the green stuff. JavaScript's inserting that for us.
Return this object.
Yep, exactly. Return, and what's its name? This. And out comes this object returned out. There it is with name is Will, score is 3, and hidden, almost in sort of light pen, is underscore proto and a bond to user dot prototype, whatever, a bond to, oh, that was not good, in pink, a bond to prototype function store. Okay, all right, we're going to do this one more time. No, we're not. No, we're not. No, we're not. We're going to, let's just quickly say, we finished running user, right? We finished running user function with a new keyword. We returned out the object. What do we do with that object? Chris. We finished running the user function. We returned out, we said whatever comes out of this function is going to be stored where, Chris?
That's going to be stored in user 1.
Very nice.
That's stored in global memory.
Very nice, dude. There's user 1. And it's, this object is now stored under user 1. So, big moment. What did we say our whole goal the whole time was we were to do? Was to write code that says user1 dot increment or dot login or any of the other hundreds of functions that might be applicable to this user1 object, or user2, or user500, or user1000. Any one of them, we want to be able to do this. Can we do this? Melissa, I go looking on, I run this line. Talk me through, Melissa, what's going to happen. User1.increment. I go looking on the user1 object.
And you see it's not there, so you look.
What's not there? Be really precise because you're right.
That function increment.
Yeah, the method increment is not there. But does JavaScript panic and error?
No, it's
I don't know if interpreters ever panic, but does it get upset and error? No. What does it do?
Look for your reference to prototype.
Yeah. So it looks up the prototype chain. This is the prototype chain. So the next one up is user. Well, not next one up. The thing which we said was next up, because we use a new keyword, is user.prototype, which is an object. There it is. And it goes looking in there. And what does it find, Melissa? Increment function. And so it calls it. No problem. It just runs it, no problem, as usual. Local memory, and we start running. The reason I just want to hesitate for 1 second is, the reason I'm cautious about, I don't love calling this the prototype, is that it's stored on the object for whom it's the prototype of, not under something called prototype, but called proto. So I almost like to think of this as the proto. The prototype bit is only the dot label on the function that was generating the object and that then had it as a property, which we then have a bond up to. So the proto of user1 is user.prototype, but people regularly, colloquially say, this object here is user1's prototype. I don't love that because it means you sort of go looking for a dot prototype on, no, there's no prototype property on here. There's a proto property that has a bond up to user.prototype. So, as we do that, as we go and look at that bond, we find the increment function and start running it. Melissa, we're now running the increment function. There it is. So, firstly, hooray. We've managed to achieve running our function on the object, and it's definitely not on this user1 object. And we've used a special syntax, the new keyword, that's made, look how pretty and clean it is. We've got rid of all these lines that we were doing before, and now all we have to do is this stuff. And these are stored in that nice automated guaranteed object over here. So Melissa just finished us off. We're running user1 dot increment.
Increment score, which is 3, 2, 4.
So let's first say, what's this in our local memory? User1, exactly. So the rule is, the basic rule is this. It's always the object to the left of the dot. This keyword in object-oriented programming points to the relevant object. So it is the user1 object. So we go looking in memory for user1. What do we find? Right, we've got this dot score plus plus. Yes, we find score and we do what with it?
Increment
To 4. Well done, Melissa. We achieved our goal. We achieved it before with object.create, but this way is all lots of automated stuff. I'm going to talk about my problem with this in a moment. But first, let's have thumbs. Man, please, let me out. When does it stop being rude? When does it stop being rude to leave? Clarification. I have a clarification. I am clear to move on. Philip has a clarification. This is, I don't think this is the most conceptually challenging thing in JavaScript, that's closure. This is the most convoluted, there's so much of it, thing in JavaScript. Philip, Melissa, clarification, was it? No, you're good. And clarification? Robbie, you got one? Let's go to Philip first. Oh, you're just that lazy.
When you put the object with the prototype and the name of the function, that means you declare the function in that object, right?
Correct. But to be really clear, there's a method. Dot prototype is always there as an empty object on every single function by default in JavaScript. But it's irrelevant most of the time, except when you use the function in this way. Karen, sorry.
Is there a dot, like capital P prototype? I think does that exist?
I want to say no in case there's something I haven't seen before, but capital prototype. Raise it, let me see, because I'm missing something. Yeah.
Okay. What about this email?
Oh, Robbie, thank you so much for teaming me up. What a smart man you are. Benefits, faster to write, still typical practice in professional code. Solution 3 is still pretty much the standard in professional code. Why don't I like it? 99% of developers, no, I say 98% of developers have no idea how this magic new keyword works. A new keyword, it makes it feel like Python. And therefore they fail interviews. And they find it really hard to debug code. Look at all this automated stuff that it was doing, that if you don't understand, it's really hard to know what the new keyword is doing. And more than that, this is the senior developer favorite interview question. What is the new keyword doing under the hood? Number one favorite senior developer question. Grads and Codesmith get it all the time. They have no problem. But most mid to senior developers do not know what the new keyword is doing under the hood. One of our favorite challenges we do these hour-long challenges in the morning each day. One of my favorite ones is rebuild the new keyword. This is a great challenge because this is it. Solution two was rebuilding the new keyword. That is a new keyword in practice. So this is the reason you want to know solution 2 is if you don't, solution 3 catches you out and prevents you from getting senior developer or even mid-level developer roles. So that is why I don't like it, dude. But I also recognize it's absolutely standard. I also don't love the way that it makes people who come from Java or C# or Python feel that under the hood, JavaScript's working the same way as those languages. Because it starts to look, this looks a lot like other languages. It ain't. Under the hood, look at all this shit about prototype bonds being made, and it makes it really hard if you don't understand under the hood to actually write any object-oriented code in JavaScript. Okay. All right. Keller, you want to add commentary on capital P?
I couldn't figure it out, but I think I read something about like get prototype, like type of. And like
So there are methods where that you can say like set prototype of or get prototype of, and that uses capital P because of camel case.
Yeah.
So that's exactly, but that is what that's saying. If you did user1 dot get prototype of, you're going to go and get, or sorry, if you do object dot get prototype of user1, you're going to see this object up here. So it is absolutely this world. Okay.
Prototype property is what that one will begin?
Say that again, Christian. Oh, it would return this object here.
Yeah, the prototype.
The prototype property of the user function. Yes, very nice. Yeah. All right, so we like solution 3, right? Pretty and clean, but don't panic. JavaScript's creators figured out that this was still not close enough to Python, because in Python, so we know these functions are going to be shared by all objects that get returned from this generator function, and in Python, just as Anne asked earlier, can I put these guys in here because all the objects are going to have a reference to them. So why not let me put them in here and just make it clear that they're not copied on every single object, but they are available on every single object that gets returned out. Wouldn't that be nice? Well, it turns out there's a new way of writing this so that you can do that. It's called solution 4. We're writing our shared methods separately from our object constructor, this guy that returns out the object itself, often the user.prototype object. Here it is, down here. Other languages let us do this all in one place, physically, not let's do it in one place. ES 2015, ES6 lets us do so too. The class syntactic sugar. Okay. So what this does, this is the final solution. It takes the constructor, the one that creates the object automatically. This is called the constructor function. Takes that and it puts it here, sort of as a mini piece of this new class thing. And then it takes the user dot. Remember this bit here? Oh, one way. It takes this. Oh, jeez. It takes this bit and it puts those functions here. No commas between them. You just literally go. So it takes the bit that creates the object and gives it a new label constructor, as opposed to using the overall title user. Then it takes any of the functions that are going to be available, like we had before, here, and it puts them adjacent, like that. And then it wraps the whole thing in the new label, in the label user. Nothing changes under the hood. All we did was we moved, this used to have the word user in front of it, it was over here. This used to be over here, and this used to be right beside it. Now we've taken the pieces and given this new syntax class. We're going to walk through it and realize it does nothing different to what we've just seen. It just sort of bonds it all into one little wrapped up place. It is what's called syntactic sugar. What that means is nothing changed under the hood. Those functions still end up here in .prototype. but we get to write it in a prettier way that makes us feel more like we're writing Python. I don't know why, but that's the goal. That's always the goal, to look like Python. And so,
Java uses class.
Yeah.
oh yeah, I'm absolutely, or any OOP language. So, but go ahead, Robbie.
I was just wondering because every developers from Java or C++,
Yep, C++, yeah.
They always have something to say about JavaScript being so loosely written. So, is this the new approach of?
Well, it's not really. No, hardly, because it's not changing anything under the hood. It's making them feel more like. No, the reason we went through solution 2 first is real engineers understand solution 2. People who come in and expect the behavior of other languages, don't understand solution 2. Real engineers who want to build great things understand solution 2. This is a nice, prettier way of doing solution 2, but it's still solution 2. Nothing has changed under the hood here, besides the fact that we've automated a bunch of the stuff, but it's still building a prototype bond for each object that gets returned out. Guys, we're going to go through this line by line, okay? Line by line.
So we automated the prototype.
Krishna, line by line. Go on then, what's the question?
No.
No, go ahead. It sounded.
So we automated the protobond as well.
But we did that already with the new keyword. Remember in the new keyword?
So, but we have to write user.prototype.increment explicitly.
Oh, you're right. Actually, nice clarification by Krishna. In this version here, because we put those things inside this new class thing, class keyword, class, these guys are automatically put in user.prototype. Yeah, that's really nice by Krishna. There is a little bit of extra automation here. Well, it's just that I would say I still say it's syntactic sugar because we were already automatically putting user. Yeah, you're actually fair.
Less chance
Yeah.
for a mistake by the program.
Yeah, you know what? Good point by Krishna. Very nice. Let's walk through it line by line though. But thank you, Krishna. That's actually a really nice. It's almost an additional automation. Just put it all in user, and you know it's going to be a user.prototype. But let's go through it line by line. So we're almost there. This is solution 4. We are almost done. Garrett, so that you stay engaged, you're going first. Garrett, what is line 1 doing here?
Line 1 is creating the class user.
Yeah, that sounds right, doesn't it? It's got the word class and the word user. So it creates a class user, which has a function that if we run user like that, will run. What's the label for that function, dude? Constructor, exactly. This is the constructor part of it, and that's the function. But we also hit this increment bit, and nothing changes. Just like before, user is both a function and an object, and it has an object bit which has a prototype property, which is another object automatically, into which, when we hit that line there, increment, what do we put? Krishna, what are we putting into this prototype?
Increment function and login function.
Exactly, very nice, thank you, man. The whole function definition, the whole thing, and login function. Has at this point anything changed? Besides that we put these functions sort of in automatically by wrapping them in the whole class thing. Go ahead, dude.
So the stuff inside gets automatically added in even though we haven't run user yet?
Correct. That's a really important clarification, and the first time I did this I wasn't sure because first time I experiment, but absolutely, you are essentially inserting these 2 lines there. That is, the assignment is happening live at that moment. Okay, not at the point of calling user. Okay, it is done, by the time you hit this point here, you have done everything that you had previously done here. So when you hit this line, let user equal the call to user, you have declared the function user, and you have filled in the increment login properties of the prototype object. Okay, does that make sense? Clear? Okay, good. Now we hit let user 1. We are almost there. 2 lines of code left. Oh my goodness. That's not too bad. 924. It's fine. All right. So Peter, left-hand side there. What's it saying?
Create a variable user.
Good. What's it called?
User 1.
User 1, right? Not user. User 1. And what are we assigning to it?
The new user function call.
Yeah, the result of the function call, the output of the function call. Yeah, so right now it's temporarily undefined until we get the result back. So, we're calling a function. Senya, what happens to our call stack when we call a function?
So we're calling the constructor.
Yeah, you can call it that. We're calling the user function.
Okay.
Yep.
Okay.
What happens to our call stack? Yep.
And then create a
US Fusion context. Very nice. This is just a function. Nothing's changed. Even though it says class, we are now, sorry to be really clear, we are now running the user class constructor function because we're throwing, so the user function that we stored is this function here. What we previously separated out, we hived it out, didn't we? We previously had it by itself. And then we added these as .prototype properties. Now, it looks different. Oh, it is just the same thing. User is the function with these two guys as properties on the .prototype. All right, so nothing has changed. We'll just do it one more time. So we're calling user, which means we're calling this function here, which means we create a fusion context, new fusion context. Senya, help me out. What's the first thing in our local memory?
The name, which is Eva, and score, which is 9.
Yeah, correct. There it is. So we can sort of say this is running the constructor. I don't really think it's necessary, but it's running the constructor bit. So the first thing is name, which is Ava, and score, which is 9. Excellent. Now we're running this with new, so nothing's changed again. We're still running this with new. So there it is, new, and we're going to say whatever comes out of running this is going to be stored in what, Senya? User 1. Great, thank you, Senya. So now the new keyword starts coming into action inside of here. What stuff's it going to do first, Senya? Can you remember?
It's going to create an empty object, this.
Very nice, and assign it to this. Very nice.
And create a bond for the prototype.
Oh, very good, Senya. Very nice from Senya. And it's stored under that hidden proto property where we'd see user.prototype sort of in there. Okay, but it's still an empty object. It's an empty object. If we were to look deep, there's a special hidden property, but it's an empty object. This equals object.create, create an empty object. There it is. But it's got this little hidden bit below the fold. So now, Senya, we hit this line. This dot name.
We're going to add a new property name and assign the name, which is Eva.
Very good.
And then add a new property score and assign score, which is 9.
Fantastic. And then what's that final thing that this keyword automates?
Return.
Sorry, not this keyword, the new keyword automates. Return
this,
which is this whole object, and we return. And what do we do with it?
assign it to user.
Very nice. Can we give a round of applause over here? This is really nice by Senya. And we assign it to user 1. So now, Senya, the magic moment. The magic moment. Name is Ava. Score is 9. And then the special hidden proto is a bond up to our what used to be called function store. When we manually set it, we called this function store. Or anything, we call it anything, right? We could call it Robbie's function store as long as we manually set that to be the bond. But now we have an autoplace .prototype, user.prototype, the constructor function .prototype, empty object, we fill it in with stuff. So now the key moment. The key moment, Senya, we are going to, our whole goal is always to be able to do this wonderful thing where our objects have our methods available on them so that we can reason and write our code very nicely. Can we do it here? When we start running user 1.increment, where do we go looking for increment?
We're going to go to the local memory.
There's no local memory, this guy's gone. So close, Eva. No.
We'll go looking at the user 1.
Right, so let's be really clear. We've finished running the user function. What's happened on the call stack, Senya? Gone. User 1 is an object in the global memory named Eva score 9.
We'll go looking for the property increment.
The method increment, do we find it? Everyone together? No. Does JavaScript give up? No. It goes looking where?
Prototype team.
Yeah, which we colloquially say to its prototype. But I like to know that it's actually stored in _proto_. And what do we find in the prototype, in the _proto? What do we find? When we run up the prototype chain, what do we find?
Reference to the user.prototype.
Aha! Very nice. And what do we find? And so we can just run the increment method. And let's create a new execution context for it with a local memory. And what's the first? We don't normally talk about what gets assigned in here automatically. What's the automatically assigned thing in here?
I believe it was saying this.
Yeah, this to what?
was to usable.
Exactly. It's always to whatever the method is being called to the right hand side of the dot of, which is user one. So we know already, and this is done for us by JavaScript. Every time we run a function, actually, this is going to be assigned to something. And by the way, PS, if the function's not being called on an object, for this, except in this particular situation here when we're generating objects automatically, if the function is not being called as a method on an object, what does the this get assigned to? Anyone know?
Can you repeat the question?
Who? Said it, wait a second, Krishna, who said something?
Isn't it like the global?
The global object, yeah.
It'll just keep going up and up and up.
No, it's just a bad thing. Let's not worry about it. For now, we know when we run dot increment to the right-hand side of the dot on the user one, we left a placeholder called this. Yeah, increment. We left a placeholder called this because we didn't know what the increment functionality was going to be applied on. Was going to be applied to user one, or if we ran user again, let's run user again with I don't know, Tim and 5, and out returns an object name Tim score 5, and it too has a special prototype on up to here, and it too wants to run, and this is stored in, I don't know, user 501, and then we want to run user 501.increment. Well, we need to make sure that that increment is going to speak to this score. So that this is a placeholder that makes sure we can write our increment function nice and general. So it can apply to user 501 or user 1, whatever the increment function gets called on. So we write this dot score plus plus. And so remind us, Senia, what is this at this point? Because that's what's to the left of the dot where the increment function is being called on. And so it's user 1, so we're really running user 1 dot score plus plus. And so we go look at user 1, and what do we find, Senia? We increment it to 1 to 10. Right, Peter, I'm with you, man. We just got to do all possible solutions to object-oriented programming in JavaScript. The most comprehensive, if not the most conceptually demanding, but the most comprehensive and complex piece of all JavaScript, and we end with this pretty Python-esque way of producing still. Our old goal was to produce an object with the data and the functionality being available to be run on that data. And what do you know? We did it, but this time with a very, very pretty structure that looks just like Python.
A lot of automation.
But with a lot of automation hidden behind the scenes. And that is why solution 4 benefits emerging as a new standard, feels more and more like the style of other languages. 99% of developers have no idea how it works, therefore fail interviews. You will not be one of those people. You are the gifted ones. Let's have fun. Wow, clarifications, good to go. Okay. Yeah, very nice, very nice. Okay, everyone. So I have one final thing to say, which is keep pair. Oh, you've got to go back to pairing. You've got to go back to pairing. It's a long ass session. We're back to pairing. There'll be drinks. Go grab drinks. Bring them back here. This isn't Hard Parts Thursday night, so there's no party going on. But you're welcome to go and grab drinks. I will need a drink after this mega ass session. But I want to add one thing. Hard Parts Challenge code. This is the penultimate day. So code application closes last Friday publicly. Hard Parts attendees get until this Friday if they complete the challenge. Today, OOP challenge. Thursday, callbacks challenge. It is your last chance to be interviewed for the June 5th cohort. Remember, the Hard Parts Challenge guarantees you interview. The regular online application, about a third of people get invited to interview from it. The Hard Parts Challenge guarantees you interview. It builds upon this that you did today. So if you complete it, you get guaranteed interview for Codesmith. But I also don't see it anywhere. Oh, because the site's down. Okay. I will give you the challenge code by tomorrow morning, I hope. If not, I guess we'll extend it to tomorrow or something. But you'll get the challenge code that builds upon what you did here, and you will have 24 hours to complete it. But for now, folks, back to your pairing. Feel free to go grab drinks from the back here to continue pairing, or just go and get drinks and knock yourselves out. Because man, this is the toughest concept in JavaScript. You should be very proud of yourselves getting this far.